So last class we discussed about the fundamental principle of accounting, fundamental principle of multiplication and a fundamental principle of addition. Now we are going to discuss about the permutation. What is a permutation? Permutation is nothing but an arrangement. Permutation means arrangement. So permutation means each of the different arrangement that can be made by taking some or all at a time. Each of the different arrangement that can be made by taking some or all at a time is called a permutation. Number of permutations of n different things taken all at a time. Number of permutations of n different things taken all at a time is denoted by NPR, or that we can also write it as P of n comma r. Number of permutations of n different things taken all at a time is nothing but NPR. Here 0 less than or equals to r less than or equals to n. So that is about NPR. So what is NPR? Number of permutations of n different things taken all at a time. That is nothing but number of ways of filling. Number of ways of filling or blank places with n distinct objects. What I am saying, NPR is nothing but number of ways of filling or blank places like that, or boxes with n distinct objects. Now you can observe here, these are the R boxes, right? So these are boxes. Total these are 1, 2, 3, 4 and so on up to R boxes. We have to fill with n distinct objects. This box can be filled in n ways. Next box in n minus 1 ways, n minus 2 ways, n minus 3 ways and so on. Last class also we discussed this box can be filled in n minus r plus 1 ways. So that is nothing but n into n minus 1 into n minus 2 into and so on, n minus r plus 1. Now what I am doing here is multiply with n minus r factorial, divide with n minus r factorial, that is nothing but n factorial is the numerator by n minus r factorial. N minus r factorial. So that is the formula for NPR. NPR is equals to n factorial divided by n minus r factorial. Suppose you want to find out the value of 8p3. How to find out 8 factorial divided by 8 minus 3 factorial. So that is nothing but 8 into 7 into 6 into 5 factorial divided by 5 factorial. Now 5 factorial cancel. We are getting 8 into 7 into 6. So now onwards, no need to write these two steps. Directly we can write 8p3 means 8 into 7 into 6. 8p3 means starting from 8, 3 numbers multiplication. Suppose you want to find out the value of 9p4. 9p4 is nothing but 9 into 8 into 7 into 6. Starting from 9, 4 consecutive numbers multiplication. Suppose you want to find out the value of 11p3. What we can write? So 11 into 10 into 9. Starting from 11, 3 consecutive numbers multiplication. But we are saying that NPR is nothing but number of ways of filling or blank places with n distinct objects. Now what is the meaning for this? NPN is nothing but number of permutations of n distinct objects taken all at a time. That means nothing but number of ways of filling n boxes with n objects. These n boxes we have to fill with n distinct objects. This box can be filled in n ways, next box in n minus 1 ways, next box in n minus 2 ways, and so on. The last box can be filled in n minus n plus 1 ways. So that is nothing but n into n minus 1 into n minus 2 into and so on. Final one is 1. Starting from n up to 1, that is nothing but n factorial or not. So that's why npn is equals to n factorial. From this discussion we can also say this one as actually npn formula is n factorial by n minus n factorial is equals to n factorial. From this also we can say 0 factorial is equals to 1, because n factorial both sides we can cancel. 0 factorial is equals to 1. So otherwise npn is equals to n factorial. Number of permutations of n distinct objects taken all at a time is nothing but npn. So another example you can see here. The question is given like this. So he is asking to find the value of n under the condition np4 is equals to 360 given. np4 is equal to 360. What is the meaning for np4? Starting from n, 4 consecutive numbers multiplication. You can observe here, this can be written as 360. 360 can be written as 6 into 5 into 4 into 3. 6 5 34, so 123 is 360. So starting from 6, 4 consecutive numbers multiplication. That's why we can write this one as 6p4. That's why what is the value of n? The value of n is equal to 6 we can write. At the same time, this is the another question given like this. The question is given 11pr is equals to 12pr minus 1. Then he is asking to find the value of r. So what is 11pr? 11 factorial divided by 11 minus r factorial is equals to 12 factorial divided by 12 minus r minus 1 factorial. Right? Now again we can write this one as 11 factorial divided by 11 minus r factorial is equals to 12 factorial can be written as 12 into 11 factorial divided by, this is nothing but 13 minus r factorial. 13 minus r factorial can be written as 13 minus r into decrease 1. Decrease 1. 12 minus r into decrease 1. 11 minus r factorial we can write. So this side 11 minus r factorial, here also 11 minus r factorial cancel, 11 factorial also cancel. We are getting 13 minus r into 12 minus r is equals to 12 can be written as 4 into 3. These side consecutive numbers. These two are consecutive numbers, no doubt this is a bigger number. That's why we can write 13 minus r is equals to 4. Therefore, you will get the value of r is equals to 9. So this is another question. So the question is given in this way. The question is given as 15pr minus 1 is to 16pr minus 2. These two ratio is given as 3:4. Then he is asking to find the value of r. Now here also we can write 15 factorial divided by 15 minus r, that means 16 minus r factorial, right, divided by 16 factorial divided by 16 minus of this one, that means 18 minus r factorial is equals to 3 by 4, right? Further simplification we can do like this. 15 factorial divided by this we can write it as 16 minus r factorial into 18 minus r factorial can be written as 18 minus r into decrease 1, 17 minus r decrease 1, 16 minus r factorial by 16 factorial can be written as 16 into decrease 1, 15 factorial. Here also 15 factorial, here also 15 factorial cancel. 16 minus r factorial, 16 minus r factorial cancel. You will get 3 by 4. Now from this equation you can find out the value of r. Okay. So this is the one more question. The question is given in this way: 1 into p of 1 comma 1 plus 2 into p of 2 comma 2 plus 3 into p of 3 comma 3 plus and so on plus n into p of n comma n. So you know what is the meaning for p of 1 comma 1, 1p1. P of 2 comma 2 means 2p2. So that's why I can write this one as, you know, npn. Npn is nothing but n factorial. At the same time we can write p of n comma r is nothing but npr. So that's why 1 into 1 factorial plus 2 into 2 factorial plus 3 into 3 factorial plus and so on plus n into n factorial we can write. Now what I am doing is, this one can be written as 2 minus 1 into 1 factorial, 2 can be written as 3 minus 1 into 2 factorial, 3 can be written as 4 minus 1 into 3 factorial plus and so on plus n can be written as n plus 1 minus 1 into n factorial. Now multiply 2 into 1 factorial means 2 factorial minus 1 into 1 factorial 1, or you can write 1 factorial. Again 3 into 2 factorial is 3 factorial minus 2 factorial. 4 into 3 factorial is nothing but 4 factorial minus 3 factorial plus and so on plus n plus 1 into n factorial is nothing but n plus 1 factorial minus n factorial. Now you can observe plus minus cancel, plus minus cancel, plus minus cancel, plus minus cancel. We left with n plus 1 factorial minus 1. So the answer you will get n plus 1 factorial minus 1. That is the answer for that particular question. So you can see the other question here. The question is given in this way: equation by using the letters of the word equation, number of words that can be formed by using the letters of the word equation. So total 1, 2, 3, 4, 5, 6, 7, 8. These 8 letters can be filled in those 8 places. That means these 8 letters can be filled in 8 places. In how many ways? 8p, 8 ways, that is equals to 8 factorial ways we can do it. So that's why the number of different words that can be formed by using the letters of the word equation is equals to 8p, 8, that is equals to 8 factorial. In the same question he is asking the number of words that begin with E, end with N. That means last place and the first place are fixed. Every word must begin with E, must end with N. So these two places are filled with E, N, because the beginning with E must end with N. So the remaining 6 letters only we have to arrange. The remaining 6 letters can be arranged in these 6 places in 6p, 6, that is equals to 6 factorial ways. Next he is asking number of words that can be formed, so that vowels together. Vowels always together. So first of all observe here Q, right? So T, N, next E, U, A, I, O. He is saying vowels always occur together. That's why consider these vowels as one unit. All these vowels can be considered as one unit. Consider this one as one box. So wherever they are moving, this box has to move together. We can keep this box in between T and N. You can keep this box in between Q and T. You can keep this box here also. But this box has to go in that way. That's why all these vowels we are considering as one unit. Now total 1, 2, 3, 4 units. So these 4 units can be arranged. These 4 units can be arranged in how many ways? 4p, 4, that is nothing but 4 factorial ways into, because whenever the box is moving, suppose this one is one arrangement. In this box, these letters can be arranged among themselves or not. They can be interchanged. They can be interchanged. That's why these 5 vowels can be arranged among themselves in 5p5, that is equals to 5 factorial into 4 factorial is the answer. Right? He is saying vowels come together. Vowels has to occur always together. That's why I am considering all these vowels as one unit. Now, this one unit we are moving always together. 1, 2, 3, 4 units can be arranged in 4 factorial ways. At the same time, these vowels can be arranged among themselves. They can interchange their places, right, in 5 factorial ways. So that is the answer for that particular question. So this is another question. This one, the question is given in this way: 6 boys and 5 girls. 6 boys and 5 girls can be said in how many ways? The first question is all girls sit together. All girls sit together. So this is boys, total 6 boys are there. Total 6 boys. No doubt they are all different boys. You can't say identical. 5 girls. So girls, total 5 girls are there. What is saying in the question? All the girls sit together. All the girls sit together. That's why all these 5 girls are considered as one unit. Total 1, 2, 3, 4, 5, 6, 7 units. These 7 units can be arranged in 7 factorial ways. At the same time, these particular girls, those 5 girls, can interchange among these places. They can interchange among their places in 5 factorial ways into, because whenever these boys and girls sitting arrangement is over, then only our process is completed. That's why till the completion of our process we have to go on multiplication. Okay. So these 1, 2, 3, 4, 5, 6, 7 units can be arranged in 7 factorial ways. At the same time, these 5 girls can interchange among themselves in 5 factorial ways. So next question is asking the number of different ways so that no 2 girls together. Girls cannot sit together. No 2 girls sit together. So that means that's why first of all arrange boys. Boys can be arranged, 6 boys can be arranged in how many ways? 6 boys can be arranged in 6 factorial ways. After arranging boys, what is saying in the question? No 2 girls sit together. That's why these are the places. In these places the girls has to sit. These are the places to fill the girls. Total how many places are there? Total we have 7 gaps are there. 1, 2, 3, 4, 5, 6, 7 places. Those 7 places can be filled with 5 girls in 7p5 ways. 7 places can be filled with 5 girls in 7p5 ways. Okay. So that is the way for proceeding that particular question. The same question that is asking like this: we have 6 boys and 6 girls are there. 6 boys and 6 girls are there. Number of different ways, so that boys and girls sit alternately. Boys and girls sit alternately. Then generally what you people will do? Arrange boys. So total how many boys? 6 boys. Total 6 boys. These 6 boys can be arranged in 6 places in 6 factorial ways. So now these are the gaps. 1, 2, 3, 4, 5, 6, 7 gaps. Yes, now I am filling the girls in those gaps. Then definitely boys and girls alternately only. But wait. So okay, these 7 gaps I am filling with the 6 girls in 7p 6 ways. Right? It is wrong. The reason is, suppose here you filled one girl, here also you filled girl, here also girl is occupied, here also girl is occupied, here also the girl is occupied, in the last place also the girl is occupied. But what happens here? Boys and girls sit alternately. Not satisfying, because here boys are together, right? So girl, boy, boy, girl again. So that's why it is wrong. But what to do? Observe here, he is asking this one, boy, girl, boy, girl. Boys and girls sit alternately. So again boy, girl, right? So total we have 6 boys and 6 girls. Now you can check here, boys and girls are alternately or not? Yes. Boy, girl, boy, girl, boy, girl, boy. Now arrange these 6 boys in those 6 places in 6 factorial ways. Arrange these 6 girls in those 6 places in 6 factorial ways. Sir, why? Why the line has to begin with a boy? The line may begin with a girl also. Yes, when the line is beginning with a girl, you will get another case. Girl, boy, girl, boy, girl, boy. Because the line may begin with a boy, line may begin with a girl. In this case also you will get the same answer. That's why total 2 ways. That's why 2 into 6 factorial into 6 factorial. That is the answer for that particular question, right? So suppose he is asking in the question is like this. So one word is there, P, A, R, T, E, S. He is asking number of ways the vowels sit together. The number of ways vowels sit together means, what is the answer for that? So vowels sit together means what to do? A, E considered as 1 unit. A, E considered as 1 unit. So remaining letters P, R, T, S. Vowels together. That's why consider this one as 1 unit. 1, 2, 3, 4, 5 units. They can be arranged in 5 factorial ways. At the same time, these two can interchange among their places in 2 factorial ways. Okay. Bye bye.